My observations. So I have 3 points to make. The first one, I'd like to remind ourselves that we actually have to exit fossil fuels by 2050. And it's a long-term goal, so we should align our short-term goals to be, of course, to manage the current crisis, but also to exit fossil fuels by 2050 for 2 reasons. We talked a lot about energy independence. I give you 2 numbers for my country, France. You can hear from my accent. Our bill in 2022 for oil and gas will be 100 billion euros, up from 40 billion euros 2 years before. And just to give you an order of magnitude, because I know the question will come, our imports of uranium are less than 1 billion, so 100 times less. And this is all the more of a challenge because we forget about it, especially in my country, because we spend our time discussing nuclear versus renewables. But our share of fossil fuels in our energy consumption in Europe at 70%, 60% in France. But it's huge to get out of fossil in 30 years. The second reason, of course, and you've talked about it, is our climate goals. And to reach our climate goals, we'll need a lot of low-carbon electricity, a lot. It will not be the only solution, but it should be about 50% of our energy consumption in 2050, so it's half of the solution. And to give you an example, again, I'll take a French example, but the national plan is to diminish our energy consumption by 40%. But to do that, we need to increase our electricity consumption by 35%. So we'll actually need to increase low-carbon electricity production in the coming years. Of course, there are different scenarios of consumption, but I know you know that. So this is my first point, just to remind this ourselves. So, and by the way, today we only have 2 countries in the EU that have decarbonized electricity production, which is Sweden and France, with a mix of nuclear and renewable. So we know it can be done. Okay, so let me move to my second point, is that I will argue that 100% renewable strategy is actually very risky for several reasons. So the first one is that it's very challenging to deploy the amount of renewables we will need to reach our goals. So we talked about permitting. Right now it's complex, not only project management but permitting. We have currently 2 laws in Parliament in France, one on accelerating permitting for renewables and one for accelerating permitting for nuclear. They're both together in Parliament right now. And actually it's harder to find a majority for accelerating permitting of renewables because we start to have a lot of resistance on permitting for wind, even for offshore wind. So this is a first challenge. The second challenge is the availability of storage technology at the scale we need. There's no country that has today deployed storage at the scale we need to deploy storage. So there's a big uncertainty, and it's actually a bet. And if we lose this bet, if we lose these 2 bets, we will have, the only solution will be to go back to gas plants. Then there are the risk of new dependencies, and there are 2. The first one, we talked about it, is raw materials. 100% renewable strategy is very costly in terms of raw material. Just to give you an example, an excellent IEA report from 2021 with the SDS scenario, multiplying by 4 the amount of critical materials by 2040. Okay, and part of it is due to the electrical vehicle, and part of it is due to, of course, electricity production. And nuclear is it's quite good for material usage. And another dependency is imports from H2, import from renewable hydrogen. Right now, the current European plan is really focused on renewable hydrogen and versus low carbon hydrogen, which includes gas and CCS, but also includes nuclear hydrogen. And so the plan is to rely by 2030 of 10 million tons of local production and 10 million tons of imports So that means we are creating a new dependency on renewable hydrogen imports. With a situation which is very complex, we're very late. We already have a plan in the US in the Inflation Act, a very simple plan. You know, you get tax credits for the lower carbon content you have in your hydrogen, the more money you get. And they don't care how it's produced. The only thing they care about is the amount of CO2 in the life cycle analysis. We have 10 texts, very complex, late, right? Which several of them exclude hydrogen, low carbon hydrogen. So we're putting ourselves at risk of dependencies from which countries? Countries, we talk a lot about Namibia. You know that the whole population in Namibia doesn't have access to electricity, so we're going to take their electricity, though first they need it for their people, or countries that have a very high share of fossil fuels in their electricity production. The third point, not going to be surprised, is that I believe nuclear is part of a solution. So nuclear is low carbon, so 12 grams versus, this is the IPCC number, versus 1,000 grams for coal and about 500 grams for gas. And 4 grams in France, because we actually enrich uranium with low carbon electricity. So it's very low carbon, and it's dispatchable. And what we see in the latest studies is that the value of dispatchable technologies is very, very high in electricity systems with a lot of renewables. So if I give you, I know I'm going to give a mic, but I give you the study that's currently based for the French strategy. It's a study that has taken 2 years to do. And they, of course, look at LCOE for every amount of energy, but what they're looking at is the total system cost with different mix of renewables and nuclear, some scenarios with no nuclear, and scenarios with, it's 2050 scenarios, and shares of nuclear going from 30%, 40%, 50% max. And what you're looking at is the scenarios with 40% nuclear, if I take this one, is 10 billion euros less per year than the scenarios which is 100% renewables, the best one, because of the value of nuclear as a dispatchable technology in the electricity system. Actually, there's not a lot of difference on the cost of the technologies by themselves, but what the difference comes from is the cost of flexibility and the cost of the investment needed in the network, so the integration cost, systems cost, right? So this is actually really good. So, of course, I'm going to have a question, so I'll answer it. How do you value, the cost of nuclear has increased? Yes, but we believe, and we have proofs of that if you do nuclear as part of an industrial program, then you can control nuclear costs and have quite good costs. The French program, it's targeted at 60 euros per megawatt hour. And we see that in China. In China, they build nuclear, they take 5 years to build a nuclear plant because they have an ongoing industrial program. They now have a capacity to build 10 plants per year, which we nearly did in France in the 70s because we did up to 8 new reactors per year. So that's what I wanted to tell you.
Thank you. That's also very comprehensive. I've got several. That's